So now they want to work with different sets of numbers and identifying what sets a number belongs to. So we kind of already talked about this. There's the natural numbers. They're going to use N for natural numbers. Whole numbers are going to use W. Integers are going to use I. Rational numbers are going to use Q. So that's different. And the irrational numbers it's pronounced Q prime. So Q with a little mark there, like an apostrophe. The first thing you want to do is take the number, like the first number is the square root of 36. You want to simplify that. And that is equal to 6. Now decide, is that a natural number? Yes. So we're just going to mark that it's a natural number. Is it a whole number? Yes. Is it an integer? Yes. And is it a rational number? Yes. Now remember, you can't have both rational and irrational. So on those last two columns, it's going to be one or the other, but it can't be both. All right, so just remember that. All right, but that one turned out to be a 6, which is one of your natural numbers, whole number. Therefore, it's also a whole number, it's also an integer, and it's also a rational number. Okay, now let's look at 8/3. Well, what is 8/3? Well, it doesn't really simplify. I mean, I can make it a mixed number like 2 2/3. It's going to be like, if I put it on a calculator, it's going to be like 2.6666, something like that. Now, I can grab a calculator to check that real quick. I just go 8 divided by 3. Make sure I'm not telling you a fib. Yeah, and I get that repeating decimal. Okay. Is that a natural number? Is that one of the numbers you started with as a kid? No. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes, because it's a repeating decimal. Therefore, it's not irrational, and you're done. So it only gets to be in one group. All right, the next one is square root of 73. Well, take a scientific calculator, type in the square root of 73. There's no number that, if you square it, is going to be 73. So this is going to be a decimal that goes on and on. I found my calculator with a square root. If I put in the square root of 73, I get about, and this is the symbol for approximately, like a wavy equal sign, 8.5440037453. That's all that my calculator shows. It's not repeating. It's not stopping. Therefore, it is an irrational number. Because it's irrational, it's automatically not natural, whole, or integer. Okay. The next one, -6. Now, -6, that looks pretty simplified. Is it natural? No. Is it a whole number? No. Is it an integer? Yes. And that means it's also a rational number. Therefore, it's not irrational. And then our last one, we've got that 3.2121121112. Now, we had a number similar to this in another video. Is that a decimal that's going on and on? Yes. Is it repeating? That's the question. Is this a repeating decimal? I'm letting you have time to think. Is it repeating? No. It's not repeating. There's no repetend. There's no 212121. It keeps changing. We know the pattern, but it is not a repeating decimal. Therefore, it is not rational. It is irrational, and it can't be any of the others if it's irrational.